This video clip is part of the EPFL introductory course on information computing and communication. It introduces a set of further video clips on information storage and management. The preceding set of video clips about this ICC course explained that there exists a fair number of memory and storage technologies, each with their own cost and performance properties, which makes them suitable at different levels of a hierarchy of information storage devices. This preceding set of clips then focused on the architecture and operation of the top three layers of that hierarchy, explaining how the migration of information between processor, cache, and main memory was automatically managed using the LRU algorithm. The set of clips further explained how the overall performance of such a three-level memory hierarchy looked almost as if all three levels were as fast as the processor in practice. It also explained that this surprising but fortunate result was due to the principle of locality, which could be optimized by picking the right size for cache memory blocks. Now, the present set of video clips will focus on the management of the lower levels of the storage hierarchy. This management is semi-automatic in that the migration of information between the levels is automatic based on the same locality and least recently used algorithm. But before it can happen, the computer must be told, in a sense manually, which information it will need to import next. As in the case of memory management at the top three level, and thanks to the locality principle and the least recently used algorithm, the overall performance of the lower level storage system looks almost as if all levels were as fast as the fastest one in practice. And the overall performance of the combined higher levels of memory and the lower levels of storage still looks almost as if all levels were as fast as the processor in practice. Before talking about management of the storage system, it is useful to review why such a storage system is needed. Remember that memory, whether on-chip, cache, or off-chip, is volatile, meaning it forgets everything as soon as power is turned off. It is expensive in terms of cost per megabyte or gigabyte, and therefore it is of limited size necessarily. A storage system is therefore essential to be able to, number one, save huge amounts of all existing data, number two, at a reasonable cost, and number three, over the very long, possibly infinite term. As mentioned on the previous slide, the migration of information between storage and memory is semi-automatic. It is governed by the same principle of locality and LRU algorithm as found in the higher levels of memory management. And it exhibits the same sort of resulting overall performance. It just requires telling the computer in advance which chunks of information will be needed next and where to find them in storage. Instead of happening in small blocks of a few bytes at a time, as between main memory and cache, information transfer between storage levels in and out of memory happens in pages of several kilobytes each typically. Where and how to store data so they can be retrieved is the topic of this set of video clips. This topic will be covered in the following 5 video clips. The first one starts with a quick technology reminder and then explains the basic principle of storage organization and management. The second clip will briefly describe the different types of storage structures that are most typically found. The third clip will then explain how information is identified and can be located, stored into, and retrieved from a storage system. The last 2 clips will focus a bit more on the 2 main types of storage systems found in practice: hierarchical file systems and relational databases.